Okay, 5.6 is solving radical equations. Of this whole chapter, the first things we did with the functions, that's kind of old stuff that you know how to do. It's just the way it's being asked. The nth root stuff and the radical operations stuff, that's a lot of conceptualizing. This is kind of probably more you guys' wheelhouse because it's solving equations, okay, for the most part. So this should be a pretty solid lesson. Doesn't mean there's not hiccups in it, but it's still pretty basic once you get work the kinks out of what the problems can present to you, okay? You have a set rule of steps here, okay? And that's those three. I'm going to change one word of these steps. Okay, I'm going to change this that's right there, to A. Okay? That's it. The rest is a fair game. All right? Now, those steps are, number one, for solving radical equations. Isolate a radical on one side of the equation. So isolate a radical on one side of the equation. Whatever algebra that takes to do, you do. Sometimes it'll be done for you already. Sometimes you'll have to add to one side. Sometimes you'll have to divide both sides. Whatever the case may be, you just have to get the radical isolated on one side first. Okay? Step 2. Raise each side of the equation to a power equal to the index of the radical to eliminate the radical. Raise each side of the equation to a power equal to the index of the radical to eliminate the radical. Square powers cancel out square roots, right? You've heard those words, I'm sure. Cube powers cancel out cube roots. That's what you're doing there. Okay? Whatever your index is, you take both sides of your equation to that power to get rid of that radical. Alrighty? After you do that, you will have some sort of equation. Chances are it'll be a linear equation. It could be a quadratic equation, but that's probably a little far-fetched, to be honest. Okay, so chances are it'll be a linear equation. And then you just solve it. Okay, whatever you got to do to solve that one. Okay. Now, when you do these, you need to make sure you check your answers. Okay? Make sure you write that down. That's what I was checking. Okay? You have to check these. Okay? Now, you don't have to show that work like normal. Okay? I don't care if you show that work or not, but you have to at least do it. Okay? And you'll see why in a little bit. Okay? Everybody good here?
Yeah.
Oh, there we go. Okay. First one, super basic. Alright, super basic. The square root of x plus 2 plus 4 on the outside of that equals 7. Okay, step 1, isolate your radical. What's the step needed in order to do that? Subtract 4 from both sides. Good. Leaves you square root of x plus 2 equals 3. Alrighty. Next step.
Square.
Now there you go. You square both sides. Okay. See how you had the radical isolated? So now we go to squaring both sides. So the square, when you introduce here, cancels out this square root, leaving you with this quantity underneath, x plus 2. X plus 2 equals 3 squared, which is 9. Subtract 2 over, so x equals 7. Very basic example. Okay?
It gets harder.
It does.
That's it.
I know.
You're giving
Now, check this real quick in your head. Okay? You don't have to write it out, but at least you need to go back here. 7 plus 2 is? 9. Square root of 9 is 3. 3 plus 4 is 7. Great. Works out. Okay, so now you go circle it. Notice how you have a radical isolated.
Yes.
Okay? That is step 1. Right there. Radical isolated on one side. It's not get the radicals on the same side. It's isolate one radical. Okay? So this will be the only case today you see like this where there's two radicals. Okay? So be paying attention to this example because it's a little more prominent than one example. It should probably have two, but it doesn't. Okay? So you have the radical isolated. The power here we need to use is what? 2. Okay? So we got to square both sides. Okay? The left side is the square root of x minus 12. We square it. What's the right side?
2 and x squared.
Oh.
And then you FOIL.
What? Really?
Mm-hmm.
Oh.
It might just be the reason why I put it on the quiz.
You put.
Not this exact one, but something like that, yeah.
Wait. What are you talking about? What? Why have to take time? It's gonna.
Now, left side goes to x minus 12. Okay? When you FOIL out the right side, I should have wrote that out. Hold on. 2 minus square root of x. Okay? When you FOIL out the right side, 2 times 2 gives you 4. Minus 2 square root of x. Minus 2 square root of x. Minus square root of x squared. Plus, sorry, plus. Yes, thank you. Okay. Now, we got a lot of cleaning up to do on the right side. See that? Most notably, we have like terms here. Okay? Negative 2 minus 2 gives you what? Negative 4. So we have x minus 12 equals 4 minus 4 square root of x. This square root of x squared becomes just x. Good. And then these two x's here do what? Cancel out, because you're going to subtract x from both sides, right? So subtract x, and if you want to kill those two birds with that one stone, that's fine. Okay?
The analogy squared.
Not quite.
No, because it's not by itself.
There you go. Okay? So see what happened? Hold tight. Okay? Whenever we did the foiling, we introduced a brand new radical here. See that? Okay, so when we did step 2, we didn't accomplish what we need to accomplish in step 2. Okay? Which can happen. That's all right. But now you got to go back to step 1 and re-isolate this radical. Okay? Sometimes that'll happen. Does it suck? Yes, it does. Will you be okay? Yes, you will. All right? So, subtract the 4 over. Negative 16 equals negative 4 square root of x. Divide by negative 4 gives you 4 equals square root of x. Square both sides. X equals 16. Okay, so if you ever see one where you have to FOIL on the one side, introduces another radical to the problem, all you got to do is go through your steps again. Re-isolate that one, re-raise it to a power, and then typically that should be the last step you do.
Quite? That's the same as no. Not quite? Is that really?
No, it's not quite. The answer is not quite no. Okay? You got to check these, and this is where a prime example where this happens. When you plug 16 up here, 16 minus 12 is 4, right?
Yeah.
Square root of 4 is 2. Okay? On the right side, you plug 16 in here. Square root of 16 is 4. 2 minus 4 is negative 2. Right side is 2. Left side is negative 2. Last time I checked, those aren't equal to each other.
Definitely not.
So does 16 work?
No.
No. Which means your answer is no solution.
I have no idea. Relax. I don't know, dude.
Everybody breathe.
Wait, there's no right hand.
Breathe means don't talk. Just breathe.
Put your hand down. Just let him talk.
Now, relax. We're going to take those same 3 steps. Okay, everybody see what's different with this problem, right?
Yeah, there's this fraction that's...
Okay.
And you have to.
Now, that fraction, hold on here. That fraction is where?
on the outside, which means you're subtracting it.
Exponent.
It's an exponent.
Oh, it is.
Okay, it doesn't really look like it, but it is.
Okay.
All right, it's in the exponent. So we have two problems. Number one, we don't know how to take a binomial to a 1/3 power.
No, we do not.
You just multiply.
We barely know how to take a binomial to a 2nd power.
True.
Okay? Barely. All right? We definitely don't know how to do it to a fraction. And by the way, it's impossible.
Okay.
So it's a solution.
So there's that.
No. Stop jumping to conclusions.
Now, PEMDAS goes parentheses, exponents, multiply. This 1/3 is still an exponent. This 2 is a multiply, which means you have to do exponents before multiplication, which means we'd have to take this binomial to the 1/3 power before you can multiply it by this 2, which means you still can't multiply by that 2 because we don't even know how to take it to the 1/3 power. You see how we're stuck?
So we're gonna learn how to.
Okay? Shields.
Would you just divide that through?
No.
No. Or would the x have a 1/3?
Okay, let's just do it.
Let's try this. What's your first step?
Plus 4.
Subtract the 4.
Plus. Add 4.
Same thing.
No, it is.
Guys. Add the 4 first. Now what?
What would you divide by?
Divide by 2.
Okay, and then you take the 1/3 over to the other side. I don't know how, but you do, right? Yeah, yeah.
Why don't you do like the division?
Yeah, it's
Yes, hiccups.
Why don't you do the division?
See how this is multiplication
Yeah.
right here? So whenever this you could divide by that, you just take out that one factor of 2. You don't need to go into it's not like you're not dividing into the binomial like you did on the quiz. Okay, see the difference? Okay. Now, we got this down to isolate to the 1/3 power, yes?
Yeah.
All right, now, any ideas on how we can get rid of that 1/3? Not quite.
It's still multiplying
Times 3.
No.
Are you taking the exponent to like each thing?
No, you're taking it to the whole quantity, but not each thing, just to this.
distributed it.
No, gosh no.
Divides the 7.
Because that goes back to foiling when we don't know how to do foiling with the 1/3.
Delete it.
McNutt!
Is it like things that?
Almost. Almost. How about we go the opposite?
Something else.
Wait, can you explain what she was thinking?
Yeah, she just,
Change the way the number.
okay? Now, there you go. She's not right, but she's closest out of everybody.
Victoria, one valid.
Hmm? No. No. Guys.
So I was.
So that means it's 6 minus 3 equals 9. 9.
Power to a power. What do you do with these powers?
Cancel out.
Cancel out.
Multiply them so there's 3 over 3, so it's 1.
Uh-huh.
Okay? So left side becomes 6x minus 3. Right side becomes 8.
Oh.
Okay?
Why wasn't it what I said?
Because the cube root won't cancel out that 1/3 power. Okay?
No, I said 3 over 1. Times by 3.
Yeah, this isn't timesing. This is power to a power. Because when you say times, I think you mean to put it back out here.
No, I definitely meant what
Well,
you
I
did.
can't read. I can't read your mind, Harris.
Sorry. Well,
Okay.
you can read Harris fine, but you can't read Harris, but you can read that.
She had hand signals. So yeah, she had visual like the 3 and the root sign. Yeah, I picked up with that.
Visually, not much.
She just said times 3. That's all I got. Can't interpret that.
Okay, so
All right, what's next?
you add.
Add the 3.
Add 3, so 6x equals 11. Guys, stop talking.
Then you divide by 6, but that's a fraction. Are we allowed to say fractions on this? Yes or no?
X equals 11/6. Anything wrong with getting a fraction as an answer? Gosh, no.
Now we have to check.
Now you have to check that. Now, I had to check a fraction? Oh, well.
Easy because you multiply
By 6, the very first thing.
66 over 6, which is just 11.
Exactly.
So that's just 11 minus 3. 8.
Which is 8.
2. She was 16 times 4.
6.
Shh.
What?
Hold on.
PEMDAS.
Plug in 11/6. 11/6 times 6 is 11. 11 minus 3? 8. What's 8 to the 1/3 power?
2.
2.
Oh, yeah, I do know.
Oh, yeah.
Oh,
4 minus 4.
4 minus 4 is 0. So does 11/6 work?
Yes.
Yes.
I'm gonna forget that.
Today's how you get.
No, hold up now.
2.
Hold on. Shh. Hold on. You add 2.
Yeah, add 2.
Okay? We're talking it out. Listen up.
Okay.
Add 2.
Add 2.
Yes.
Go by 3.
Can I just go straight to 2/3?
Yes.
Yes.
Is everybody okay with
Yeah,
that?
get rid of the 3.
Okay.
Go down straight to 2/3. Yeah. Alright, nice.
Add 2, divide by 3. Okay, everybody good?
Wait, why do you get 2 thirds?
Add 2.
Oh, you have to-
divide by 3.
It equals 2. It equals 2 because you have to do.
Got it. We're good now.
Oh,
Jacob, keep going.
Yes.
Yes. You're about to tell me to shut up.
No,
Shh.
he's not saying this to me.
Next.
To the 3rd power.
Cube both sides. If, as long as this is a 1/3, yes.
So if it's like a
Is it-
1/4.
If it's a 1/4, you do fourth it. Right.
Okay.
Right.
How high are you gonna
Not much higher than 4.
Okay. Because I know on the.
Then they get big.
Okay.
Right. Okay. Cube 2/3.
Is it not 8 over 3?
8 over 27. Cube 2. You didn't cube 2. You cubed
Well, between one of you, you got one of you cubed the first one of you cubed the second one of you cubed both.
27.
What's yeah. Times it by each other 3 times, right?
Yeah.
And when you multiply fractions, you multiply the tops together and bottoms together, right?
Yeah.
So 2 times 2 times 2,
8.
3 times 3 times 3.
8 over 27.
Yeah, I did that too.
Okay? Now, fun fact. Ready?
Yeah.
You put that in your calculator, you're probably going to screw it up.
Yeah.
Because you know what you're going to do? Here's what you're going to do. I know exactly what you're going to do.
I did not put the parentheses.
Exactly.
Yeah,
Oh, I always.
Okay.
Exactly.
I'm actually.
All right.
about that.
Shh. Take these. Rest of the day.
I don't know if I want to throw it.
That's fine.
What if this is burnt?
Here, you can move these.
Yeah, because you threw it.
I'll make the school buy another one.
Give me new
I don't care.
Did I calculate?
No, but I'll make them. All right?
Lay it on the stand.
You guys need to stop relying on them as much as you do. Because if you did, for lack of a better word right now, dumb things like messing this up wouldn't happen. Okay? I'm serious. Dumb things like this wouldn't happen. Okay? Now, your next step is to add 1, right? Okay. Well, also, without our calculator, yes, this could be painful. Ready? If you're going to add 1 to both sides, the denominator, when you add this one, needs to be what?
1.
No,
27.
27. What's 27 going to be under if it's going to be 1? 27.
Oh, what?
So that's 35 over 27.
Because 27 over 27 is 1. See? And you need common denominators. Right? Add the numerators, so that gives you what? 35 over 27. Now, divide by 5, also known as what? By
Oh,
1/5. When you do that to both sides, what happens here?
they can't, they,
7.
They reduce.
I'm working on it, yeah. And then you have to check that. Now, not going to lie, that check is quite ugly.
I got confused.
Okay. That check is quite ugly because you will end up having to take a fraction up here to the 1/3 power. Okay? That you can use your calculator on for sure, 100%. Okay, homework is page 355, 1 through 13. You have a lesson check tomorrow. All right, lesson check is tomorrow. Listen up here now. Lesson check is tomorrow. Rest of this week that I see you guys is review, which I believe would be tomorrow and Thursday for y'all. Next Tuesday is review. Okay? For you guys, because I have you guys next Tuesday, I believe. Next Wednesday is your homework quiz from nth roots through this. Okay? That'd be 3 worksheets plus this book. Next Wednesday. Okay? Yeah, the 21st. 3 worksheets plus this book. Your test is next Thursday.